Hey guys, Miss Davis here. This video will cover Unit 4, Skill 3, Proofs Part B. So we've got proofs involving some easier proofs. So go ahead and take a moment to pause the video, write down your essential question. How do we use given information to prove triangles are congruent using sides and angles? Okay, so pause the video, write that down. Okay, so now the first example, we've got to look for three pieces of information whenever we are trying to prove triangles are congruent. So here's our methods: side, angle, side, 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 angle, side, angle, 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 side, or HL. So when I look at an example and I've got some givens in our first example, BD is the altitude and angle ABD is congruent to angle CDB. So let's go ahead and start off our T-chart. So we've got statement and reason. Go ahead and write that in. Okay, so our very first given is that BD is the altitude. So we got to write that in. BD is the altitude. I'm going to abbreviate ALT. What's our reason? It's a given piece of information. So now we have to use this information in the givens to try to come up with like a case to build using three pieces of evidence to prove that the triangles are congruent. Okay, so our altitude, what do we know about an altitude? Well, if we remember from Unit 1, an altitude creates 90-degree angles. Okay, so and that is because we have perpendicular lines forming when we have an altitude. So if BD is the altitude, then that means that there's a right angle here and a right angle there, and they're both 90 degrees. So once we have that labeled on our picture and use that vocabulary word, we have to take a moment and before we can say that we have 90-degree angles, we're going to say that BD is perpendicular. So an altitude is always perpendicular to the opposite side. In this case is AC. And our reason is that altitudes form perpendicular lines. Okay. And then step 3, after we've stated that we have perpendicular lines, we can now say that this angle ABD is a 90-degree angle and that CBD is also a 90-degree angle. So we can say angle ABD we can actually just say that they're congruent. So is congruent to CBD. We can say and are 90 degrees. Okay. Our reason is going to be that because we had these perpendicular lines from part 2, that perpendicular lines create congruent 90-degree angles. Okay. So what I usually do at this point is off to the side, once I've proven a pair of sides or angles are congruent, I usually label that I have used, or sorry, that I've proved a pair of angles congruent. So looking at my, my methods up here, I know that I'm not going to be using side, side, side because we are obviously going to use one of the angles congruent. Okay, our next thing we have to do is look at our next given. So our next given is right here. We need to write that down. So step 4, angle ADB is congruent to angle CDB. And let's look at let's do our given first for our reason. So we got to go to our picture and mark up that angle. So ADB is right here, is congruent to CBD or CDB right here. So there's another pair of angles that are congruent. So if I have a pair of angles, they're kind of like a freebie here. I don't have to do anything to prove them. They're already given to us as congruent. So far, looking at our proofs, you see how it's either angle, side, angle, or angle, angle, side, because I have two angles on this picture that are congruent. Now, we ran out of givens, so we already used the altitude and we used our free pair of congruent angles. So our next thing we have to do is look for any vertical angles. So over off to the side, I'm going to say, once done with your givens, so once used all givens, look for either vertical angles or that reflexive side. So the side that is shared by both triangles. So in this picture, do you guys see, hopefully, that we have a reflexive side that is shared by both triangles? The left and right triangle is side BD. So we've got BD is congruent to itself because we're using BD in both triangles. So we have to say that it's a side that's congruent in both triangles and that it's also congruent to itself. And what we say here is the reflexive property. Okay, so that side BC is obviously a side. So now we have to determine, is it angle, side, angle, or angle, angle, side? So we have to start with one of the three pieces, and I would probably start with so we have an angle, we have a side, and we have an angle. If I look at both triangles here, I have that 90-degree angle, the reflexive side, and the angle. And you always want to go in the order that they're the closest. So you go angle, you're closest to the next side that's congruent, then to the angle. You wouldn't want to go angle all the way over here, angle, and then side, because that would be wrong. So don't write that down. So you always want to go your shortest route. So I've got to do my last statement once I have three pieces of evidence and state that triangle ABD is congruent to triangle CBD, and our last reason down here is that angle, side, angle. Okay, because they have two angles and a side, and that side is in between the two angles that's congruent. Okay. Now, yes, all the other sides do look like they're congruent on both triangles, but we didn't have any evidence in our givens to prove those particular ones, so we can only use the ones that we were given and the reflexive side. Okay, go ahead and I'm going to pause the video. You set up your T-chart. Okay, so I've set up my T-chart and I've also stated my first given. So E is the midpoint, is the keyword here, of CD. So I'm going to go ahead and highlight CD so we can identify what we need to do with that line. So from C to D, and they're saying that E is the midpoint. Well, if E is the midpoint of that line, then that means that it's right in the middle of it, which means that CE on the left or the top of it and ED on the bottom are two congruent pieces that have been split in half by the midpoint. So I'm going to use the midpoint to be able to prove and say is that CE is congruent to ED. Okay, and again, I can only say this because of the fact that it says that E is the midpoint of my line segment CD. So, and what we're going to do is we're going to define the word midpoint over here. A midpoint divides a segment into two congruent segments. Okay, so that's our reasoning for why we could say that CE and ED were congruent. Now, I know that it might look like AE and EB are also congruent, but does it say that E is the midpoint of AB? No, it doesn't. So we actually can't just assume that. So our next thing we have to do is move on to our next given. So our next given is that angle A is congruent to angle B. So let's write that in. Angle A congruent to angle B. Again, that's a given. And let's mark this on our diagram. So angle A is congruent to angle B. Okay, off to the side, I do want to just take a moment. And for step 2, we proved this pair of sides on these two triangles are congruent. So see, it's these two, AED and CEB, we're trying to prove are congruent. pair of sides, we've got a pair of angles given. And so now our last thing we got to do is look for a third piece of evidence. So do you see how we have run out of givens? So we use the midpoint, we use the pair of angles that they gave us. Now what we have to look for, we wrote off to the side, are vertical angles and a reflexive side. So do we have vertical angles in this picture? Your answer, you should be thinking, is yes. So vertical angles form here. I'm going to put two arcs to show that these ones are congruent to each other, but they're not congruent to angle A and angle B. So I've got vertical angles, so I'm going to go ahead and write step 4 is angle AED is congruent to angle. Now if I started with angle A, I have to start with the same angle that matches up with A. So angle A matched with angle B, do you see how those are congruent? So we're going to read it BEC. Okay, because we want to match up those corresponding parts. So step 4, we got to say vertical angles. We can't just say vertical angles. We got to say vertical angles are what? They are congruent. Okay. And then off to the side, I'm going to go ahead and put that I have another pair of angles that are congruent. So I'm going to put an A over here. Okay, and then we just have to determine in which order do we put the side in the angle and the angle. So when I look at my diagram, I've got an angle, and a side. So do you see how I wouldn't go, side all the way over here, angle, and then hit them up that way, angle. So what we want to do here is we'd want to start with either the angle on the left or the side on the right. Start here and read it this way. So angle, side. So those are the closest three markings on our diagram. So our theorem is going to be angle, side. So step 5, our last step in these proofs are always to prove our triangles are congruent. So triangle AED is congruent to triangle BEC. And our theorem was angle, side. Okay? All right, go ahead and flip on over to the back side. Go ahead and set up your T-chart and your one and only given for this one. So I'm going to pause the video, go ahead and set that up. Okay, so our only statement or given here is that BD is the perpendicular bisector of AC. Now if you look over here what I have written in blue, the perpendicular bisector, whenever it's given as a given, is I call it the 2-for-1. So it's a 2-for-1 given, which means you are able to prove two things with one given. Well, the perpendicular piece shows that you can have 90-degree angles, and the bisector piece, so our perpendicular piece goes with our 90-degree angles that we can prove, and then the bisector piece shows that we can, or allows us to prove congruent sides. So when I look at the picture, we've got BD is the perpendicular bisector of AC. So if it's the perpendicular bisector, that means that there's 90-degree angles by where BD hits the opposite side. So our next statement can be that angle ABD. Another way that we can say this is that angle ABD and angle CBD are congruent 90-degree angles. Okay? So, how do we know that? Because perpendicular lines form congruent 90-degree angles. Okay, so we've used up, we didn't have to restate that they were perpendicular because it already says that BD is perpendicular, okay, to the opposite side, we're assuming in this case. So step 3 is to use our bisector piece. So how are we going to use the bisector piece? Well, if BD is a bisector of the opposite side, so if BD comes in here, then it's cutting the opposite side in half if it's a bisector. So that means that our AB and our BC segments to the left and right of where B, so B is actually the midpoint of AC. So that allows us to then say that AB is congruent to BC. And what we have to do over here is we have to define the bisector word. So you have to say a bisector. We can actually add a segment bisector. Divides a segment into two congruent segments. Okay, so you see we've used the perpendicular definition here and the bisector definition down here. So two pieces, 2 for 1. Okay, now we are out of givens. That is all that this problem has given us, so we can cross it off. Now we have to look for vertical angles or reflexive side. So hopefully you do see that these triangles border each other and share that same side BD. So we're going to go ahead and use that reflexive property again. So BD is congruent to BD, and our reason is reflexive property. Okay. All right, so let's go ahead and figure out what we've got. We've got a pair of angles here. We got those 90-degree angles. We've got a pair of sides, and we've got another pair of sides. Okay, so in our picture, we've got a side, the 90-degree angle, and the reflexive side. So hopefully you can see on both sides, we've got side, angle, side, and they're directly like right at the same corner there. So it's side, angle, side is our theorem. So our final statement is triangle ABD is congruent to triangle CBD, and that is because of side, angle, side. Okay. Okay, so now our last example, go ahead and set up your T-chart and write down your first given. I'm going to pause the video. Okay, so go ahead and make sure you have this written down. So our first given here is triangle ADC is isosceles with vertex angle ADC. So I'm going to outline angle A to D. Whoa, that's a bad outline. ADC is the vertex angle. So this angle up here at the top by D is the vertex of the isosceles triangle. And if you guys remember in isosceles triangles, if we draw out one right side up, if I have two congruent sides, then these two down here are your base angles, and the one angle at the top that's not the same as the other is called your vertex angle. So in this picture over here, our vertex angle is angle D, or ADC, which means that we can draw a conclusion that the two, that this side right here would then be the base, and AD would then be congruent to DC, and angle A would be congruent to angle C, because those would be your two congruent base angles. So we actually have two things that we can use or prove based on the fact that this is an isosceles triangle. So we can start with angle A is congruent to angle C. And again, we can do this because we know the properties of an isosceles triangle, and we're going to define them over here. So we can say an isosceles triangle has two congruent base angles. Okay. Now we can also state that since they told us it's isosceles and that there's the vertex angle there, that AD is congruent to CD. And we can also say that an isosceles triangle has two congruent, and they're not called the base, they're called the two congruent legs. Okay? All right, so we have one more given left. So we've used the isosceles triangle one. We've got AB is congruent to CB. So that means AB and CB are going to get two different tick marks there. Okay, because they're different lengths than the legs. So we got to write that in. So AB is congruent to BC. and that was a given. Okay, so step 5, let's see what we got. Do we have enough to prove our triangle's congruent? Well, let's see, we have a pair of angles, those base angles, we have the pair of sides, and we have a pair of given sides from our givens up here, which we already used. So if I label them on the picture, I have a side, an angle, and a side. And do you see how the angle is in between the two S's? So it's going to be side, angle, side. Okay, and just a refresher that tick marks always show congruent sides. Those little arcs always show congruent angles. Okay, so we have enough. We have 3 pieces of evidence. So our final statement is ABD is congruent to triangle CBD. And we've got the side angle side theorem. Okay, now if you notice, we could have also used one more property or one more statement and reason, and it would also be that the reflexive side there. So you could have also used that BD was congruent to BD, and then use side, side, side. Or you could have used, actually that's all you could use for that one. Okay, so go ahead and take a moment to write your summary and try some practice problems.